Nicolas, you're Bogdan. I'm living in Bucharest. You're living in Timișoara.
Yes.
And we are in Etam. We are very pleased to sponsor this event of Vox Days today. Always have been a great event over the last couple of years, and we are very pleased to sponsor the event for this year in particular. Maybe a quick word on what is Inetum. Inetum is a very large group, 26,000 people all over the world. Initially, we started in France, but we are very active in Romania and in many other countries. We have great opportunities for developers within the company, so feel free to send us a message if you have any interest to join us. Among the key messages, I think we would like to emphasize that we promote entrepreneurship. We expose our consultants to the most exciting projects on the local level and also international. We favor self-starting spirit, people who like to train and upskill and find progressively a better career path over the years. We have a lot of opportunities. And today we're going to discuss the challenges of a distributed system in IT. So essentially we're going to talk about microservices. I think this is the key word. I'm not the expert. Bogdan is the expert, but I'm very pleased to, let's say, make the conversation more dynamic by asking questions as the presentation goes on.
Thank you very much for the introduction, Nicolas. I will also quickly present give an overview of the presentation. So the topic will be challenges of distributed systems with an emphasis on the particular type of distributed systems, meaning microservices. I will also provide an overview of the differences between them. So the reasoning of the whole presentation, we want to provide a high-level overview of the evolution of enterprise software architecture, so from a zoomed-out overview in terms of their deployment type, so starting from the good old monolithic deployments and transitioning eventually to microservices, to understand especially the reasons why some applications might transition and some others might not transition, so also trying to clarify that. Communication and data storage models for the two types of enterprise applications and with the benefits and challenges for each of them. Overall benefits, challenges, trade-offs for both types of deployments so that we will have a hopefully better understanding on the benefits of each and the challenges of each, to understand hopefully better that there isn't a best case scenario, and there isn't a best solution. And also, there's no such thing as a free meal, so there isn't anything like
free lunch,
a free meal, free lunch, free whatever. Transitioning, it doesn't come without costs. Short overview of what distributed software systems and microservices are, and then challenges when migrating a project. So these will be our topics. So from a monolithic architecture to a microservices architecture. That micro is in parentheses because it depends on how micro it really is. So,
but by definition, it shall be small.
By definition, it should be small. So the overhyped and very present in the last couple of years, I think, CV-driven development present in a lot of CVs, microservices. We already had that very short overview of ourselves. I'm mainly working as a trainer and consultant within the Java ecosystem, Spring and DevOps, meaning the Kubernetes and Docker technologies. Nicolas has already introduced, so we'll skip forwards towards an overview, fast introduction of enterprise applications, so that we set the high-level context of why and what we are speaking about. Enterprise applications, regardless if they are written in Java or not, but our focus will be, let's say, overall towards Java applications, are medium, large, or huge applications, and always existing because they are implementing the business functionalities needed by a project. So all of those enterprise applications, regardless of the domain in which they exist, they are always started from this, and they exist from the same reason: implementing the business functionalities needed by a project. So, of course, depending on its domain, how usually, at least until the recent years, they were written in a single programming language.
So this is the case for monolithic application.
Exactly, this is the case for monolithic application.
Big size,
big size applications.
One single programming language.
Exactly. And evolving into bigger sizes as that application grows. Packaging and deployment, especially monolithic deployments. Monolithic meaning an entire application running in a single deployment unit, a single package or a single box. Some of them are evolving towards microservices in the recent years, entirely depending on their scenarios, their use cases, and their actual usage. So the focus is on just some of them. Those applications are collaborating, that application, an application is collaborating with infrastructure services and or some other systems for persisting the data. Usually one database and data exchange using interacting with messaging brokers, other systems through synchronous and asynchronous communication. Hopefully we'll have enough time to go over that because that's one of the critical aspects.
For microservices.
For actually, I would say for any system-to-system communication, just providing it very high level, exactly. A very short overview of distributed systems versus microservices so that we provide a little bit of context and maybe some initial answers on what is the difference between them. First of all, we will see that there are a few deployment sizing and management differences between them. Also worth explicitly stating that the microservices are a type of distributed systems. So they are just a particular and more recent and more, let's say, modern and...
Could we have a distributed system of monolithic services?
We already have, and there are a lot of them, and I'll try to provide some context on that. So considering some systems, in there are system 1 and system 2, which may or may not share a database. Those are distributed, that's a distributed system formed from two monolithic applications. So those big or very big boxes. Let's briefly refer to them as traditional distributed systems. Those traditionally distributed systems are running an entire application. So that means multiple services running in them. Services, as we've mentioned, are determined, their number and their sizing is entirely defined or determined by the needs of that project. So the bigger and the more successful that project is, the more services there will be in there. Deployed and running either in a physical or a virtual machine, so they are just running somewhere. And data usage and sharing, multiple systems might share a database if they need any common data. Replicating them, haven't included that, but usually means just creating new instances from those boxes. So this is the traditional way to use distributed systems.
Which has some benefits.
Which has a lot of benefits, and we will go over the benefits in the next couple of slides. Mainly, it was a simple model. So we'll go over the simple because that needs some context. In comparison, the microservices are optionally using, each one of them using a database. Might share a database, but hopefully we'll get to that part as well. So microservices running a single business service. This is the important aspect to mention for now. So just one, not a lot of them. Deployed and run, so they are deployed and they are running in containers in order to have an isolation from the place where they are running. So we can just briefly associate container with isolation for now. Data usage, each of those services has its own database if it needs one. So that's an important distinction. And scaling them and high availability through a containers orchestration platform, usually that's a Kubernetes or something on top of it. So this would be a very, very simplistic attempt to provide an overview of the distributed systems versus microservices with the...
So this is the new way.
This is exactly, let's say, the contemporary way, the cloud native way of creating applications. So smaller applications, loosely coupled applications, and just handling one business service.
Can you define loosely coupled?
Loosely coupled means there is no strict coupling between them. I mean, no referencing of a certain service or of a certain URL to which to access them.
meaning that they can run autonomously?
Exactly, autonomously and coordinated through an orchestration platform.
Okay.
Okay. A few details on the deployments, data storage and communication models for the two types of architectures, so that we will go further on into the evolution from one to the other. The monolithic architecture traditionally is assembled in that single deployment unit for Java applications running within a JVM. So everything is bundled and running from that JVM. The services are communicating through simple class calls, so just invoking some other classes, using data from one or more infrastructure services, databases, messaging, big data, entirely depending on what that application needs. So just collaborating with the infrastructure and might or may not collaborate with other systems, only if they need to do that. So again, business driven. Everything is business driven. Microservices, as a comparison, as a very simple comparison, each of those services is running in its own lightweight JVM. So much more lightweight, much easier to scale, much faster to deploy. And those composing services are communicating through various inter-process communication methods, because they usually need to communicate to perform any business functionality. And they use their own databases if they need one. So that's the shortest overview of a few differences in terms of deployment, data storage, and communication. Quickly going over the benefits of the monolithic architecture in order to understand why it was used and why it is still used, and why there are a lot of people which are still huge promoters of the monolithic architecture. And I totally understand and support that, because depending on the scale of that application might be good enough, might be entirely good enough.
So let's maybe clarify. If we are starting a project, it's maybe good to stick to the monolithic.
Definitely. Definitely recommended. Definitely.
If you want to build a large application with fast, let's say, response to changes, the microservices are the necessary way.
Yes, but it's a big overhead and it requires a lot of setup and a lot of discipline in order to start with them. So the overall recommendation, not just mine, but overall in the industry, is to start with the monolith, and when it becomes too much to handle, then to consider the migration. Exactly. But to consider the migration, which is not coming as a free lunch or free meal. So an overview of those benefits, simple to develop, because most applications are focused on that. Easy to make any radical changes, easy to change that code and or the database schema, rebuild and redeploy. I haven't included there the retest, but hopefully it goes without saying that we need to rebuild and redeploy. Retest
that. Can I change you a bit on that? Because radical changes on monolithic architecture looks like something difficult to do, because eventually it's a lot of code.
Exactly.
And therefore, refactoring this application may be lengthy, may be painful.
It might be very painful, and might be very painful in terms of the amount of changes required in there. But the fact that everything is kept in a single place, in a single box, it is easy where to make those changes. I mean, everything is placed and located within that box. There aren't different boxes that need to be changed. So just that easy wording in there just refers to that. It is not stating anywhere simple to make, not a simple thing. As you said, that may require a lot of effort, may require also a lot of effort for testing, but it's located. So it's located within that single application. Straightforward to test. Unit integration and component testing. We won't go a lot over the importance of testing, but I hope that everyone is more than aware about the importance of testing. Straightforward to deploy, straightforward to run, either in a web or application server or standalone, especially for the last couple of years. Standalone applications just started and they are running and orchestrated, as we briefly mentioned. Easy to scale, run multiple instances behind the load balancer. Once again, the orchestration, containers orchestration platforms are using that. So the overall reasons, simple, easy, straightforward, and easy. So these are some of the reasons why the monolithic architecture was and it still is enough in some cases. In a lot of cases, once again, depending on the growth of that application. So more than sufficient in most cases. Challenges, and I'll start with there are two categories: organizational, so those
teams,
of course managed by at least one team, usually several teams split by their handled services, because as we have discussed that monolithic application runs several services, so business services, so they usually are managed by different teams. So need to collaborate and synchronize on any feature or change or bug fix. And the more people there are, the more synchronization overhead. So of course, they need to be aligned on those changes. Technical, starting with the biggest one of them, cost of change. Meaning every code or configuration change, the whole application or the applications must be thoroughly tested. Again, not going into a lot of details on testing, but hopefully or ideally those tests are automated. So ideally they are not manual tests, because we people are very error prone. That automated testing is not error prone, not that much at least. Repackaged, again, because we need to repackage that whole application. And then redeploy it, usually with some downtime.
Yes.
So for that downtime, the application is known not to work. Maybe that is done during the weekend or during the night. So let's say the old way. Exactly. Less impact, less business impact. Single point of failure. If one of those services fails in a fatal mode, for example, I don't know, a buffer overflow or anything, it might stop the entire JVM. So might be on more than a single, I don't know, or not fatal error. Scaling becomes more difficult as the deployment size grows, because of course the size of that box becomes bigger. So the bigger it becomes, scaling becomes a little bit more difficult. More powerful machines are needed, more storage, more memory, more of everything. And of course there is a restriction, an inherent restriction of using a single technology, both on the front end and the back end. Again, this was and is in some cases the case of that application bundling both the front end and the back end. Of course, if that is a web application, if it's a middleware application, then most likely it will have just the back end, but it is still a single technology. So some restrictions and some impediments, mainly the most frequent of them being the cost of change. Continuing.
Can we just stick for 1 second? So in terms of repackaging, means that the deployment of a new version of the application could be done still manually. I don't have that many microservices to bundle into a container and ship to production.
Of course, building that application manually is one of the many things that can be done but should not be done. Why? Again, because we people are very error prone. So everything that can, and there are a lot of aspects that can be automated, should be automated. So it can be, but it should not be. So there is a common practice of continuous delivery and continuous deployment, meaning
that
continuous
microservices.
Not necessarily. It can be also for the.
We tend to couple of all these topics: the cloud native, continuous integration, continuous delivery, microservices. But actually, it's because they came all together at the same time. They emerge somehow as topics on the same time, but they can be decoupled.
They can definitely be decoupled. I mean, continuous delivery and continuous deployment can be done with monolithic applications.
Okay.
The important aspect to keep in mind is that the whole deployment and delivery takes longer, because building takes longer, packaging takes a little bit, testing, ideally as much as possible, takes a long time, because there isn't a single business service that is tested. There are a lot of them that need to be tested, and not only to be tested individually, but together,
because they're coupled.
Exactly. Then comes another challenge, and one of the very interesting, at least in my humble opinion, aspect. Nothing fails like success. And that's
So stop
important.
for a second. Nothing fail like success.
Exactly. Whenever something gets successful, either
Yes.
both an application or a person or any sort of entity, let's just call it generically entity, whenever it becomes more successful, it has higher chances to fail. I know that's not, it might be counterintuitively, but it's definitely the case.
In the case of an application, why is it? Because the team has been successful to roll out a nice application, and therefore people are coming to you with additional features, additional services, and it grows with time.
Exactly, and we'll give more context on that. So successful projects might outgrow the monolithic architecture. So whenever they are successful, they might become in time just too big. Mm-hmm. There is no project, most likely, or at least not a lot of them, which are not successful that are outgrowing the monolithic architecture. Because if they are not
small,
exactly, they stay small enough or decent enough. So this is, in my opinion, or may be counterintuitively, but it's definitely an important aspect to keep in mind. Successful applications and projects may outgrow the monolithic architecture. One example that comes into my mind, Netflix. Okay. Netflix was using for a very long time a monolithic architecture until more or less 2012, when they had a huge problem because of some code error, which maybe wasn't tested. And their whole production was offline for, I don't know, 1 or several hours. Mm-hmm. That was the point when it was too much for them.
It was necessary to shift.
Exactly. So it wasn't a deliberate, proactive migration. It was just,
they did the whole and decided to change. Exactly. What about Amazon? I think they started also as a monolithic application.
Exactly. Amazon was another another company that started with monolithic applications. Mm-hmm. eBay as well. Mm-hmm. So a lot of others that started with monoliths and in time have migrated.
They had to do it.
Exactly. So it wasn't an explicit intent, I think, most likely. It wasn't, I don't know, someone thought in an early Monday morning, let's migrate to monoliths. So it wasn't, let's migrate to microservices. It was a result of their growth, and because things were just slowed down. So adding more features, the code base becomes larger and more complex. As it becomes more successful, of course, the development teams will grow. So that means the code base growth rate will be increased, of course, because more code base will be added, management overhead. So
we have the Amazon.
Exactly. Their recommendation of having 2 pizza teams. The 2 pizza teams is
the size of the team?
Exactly. The size of a team being fed by 2 pizzas, but of course with the explicit mentioning that not 1 square meter pizzas.
American size or?
No. European sized and not extremely hungry people sized.
Okay.
So decent people sized. Decent hungry people sized. So some applications may evolve in time into difficult to maintain monoliths, meaning small development teams grows into several Scrum teams. And as that application outgrows, the architectural model might reach a stage called the monolithic hell, where development is very slow and very painful, and agile development and deployment close to impossible. So when if an application reaches that stage, it has 3 alternatives, 3 possible approaches. First of them, maintaining that monolithic architecture. And I think this is the case for a lot of applications from this world. They are maintaining what they already have. So with inherent benefits and challenges, because the whole setup is already set up for that. So that's why they are maintaining that big box or monster or however we call it. They are maintaining.
If you have new features to be included in this monolithic, you can always start it as a microservice. Would it be possible?
Of course, they can do that, but then we need to switch to the trade-offs. We need to switch to the other world to see what that entails. Because in there, you already have a huge change of communication. The communication is no longer internal, meaning within that box, but it is between 2 boxes. And when those 2 boxes communicate, there are some aspects that we need to clarify. We'll get to that. So maintaining that until it hurts too much. Hurting, of course, that's an quote-unquote, it means becoming too painful to evolve it, to maintain it. So it might hurt too much. splitting it into some smaller modules or some mini monoliths, or some, as someone called them, modulates, meaning modules, but still those modules would run several business services, or migrate into a microservices architecture. The first two of them would be just delaying that transitioning. Again, might be enough. If it's enough or not, I think it is entirely a business perception. So are they evolving in a good enough pace? Can they make changes? Can they evolve it? If those questions are predominantly yes, then
stick to that.
Stick to that. So it's not necessarily a must migrate to them. It's just trying to provide hopefully sufficient context on when a certain project will or might migrate, if those changes become too painful. So not a deliberate.
But I guess many, most of the developers would like to switch to microservice architecture. It's the state of the art these days.
Not only the state of the art, but I think it's also human nature. Human nature to go to the shiny things, to go to what's new and shiny, and just
it has some benefits there.
Definitely, but I think a lot of people just want the benefits from that migration. But again, there's no such thing as a free meal. So those benefits do not come with trade-offs.
Okay, so it has a cost to migrate.
Exactly.
So quick question: what is the immediate, let's say, benefits for the business, for the product owner, for the stakeholders that are using the application to move from monolithic to microservices?
After that migration is done, which is a long process, the development speed and any change
will accelerate.
Exactly. So it's reduced. It will be reduced, but after a lot of initial setup, and we'll discuss about that initial setup, because that initial actually not only setup but migration. So an overview of these two architectures and worlds, so the monolithic versus the microservices, we can easily imagine as the monolithic application as being this, hopefully not that aggressive shark from there, and the microservices being these cute little fish which are just joined together and trying to scare that. So going from this into this, and the eventual solution, so when those issues become too heavy, meaning cost-wise, the architecture solution, meaning the microservices architecture, at a high level means going from a huge box towards a lot of smaller boxes and more agile and more dynamic boxes. So easy already, hopefully easy to understand the reasoning. Quickly providing an overview of what it is.
Yeah.
Services.
We need to slice this big box.
Exactly, we need to come to the slicing. So services-oriented architecture composed from loosely coupled services. Again, they are decoupled in terms of what they are doing. Implementing a business functionality determined by a concept which is called the bounded context, meaning a certain business context. So isolated and clearly defined bounded context, but not something that is very easy to get to, as we'll further discuss. And also an alternative or a complementary definition, an architectural style functionally decomposing a project in a set of independently deployable services. And this already sums up one of the benefits, that with this architecture, we can deploy all of those services independently.
So and if some developers develop a new feature on one particular area of the application, it can be shipped into production much faster. Exactly. We don't need to wait for the others.
Exactly, and also if a certain service is not working,
yes,
it will not bring down the whole application. So there isn't anymore a single point of failure. So the whole.
But this is the loosely coupled services that
yes, loosely coupled services, and just no longer having a single point of failure. Meaning that application, which is that box, but having smaller pieces.
So my microservice can fail and the others can continue to deliver their services.
The overall state of that application will be, for some time, degraded.
Sure.
But not still unavailable.
Still up and running.
Exactly. So we may not be able to order that shiny thing on Black Friday.
If I want to check, for instance, a microservice with the inventory position, it may not be responsive.
For some time.
So timeout or... but we can have a retry, we can...
Okay. Exactly, but the whole infrastructure will work. A few benefits, and then to go to the trade-offs as well. No such thing as a free lunch or meal. So continuous delivery and deployment of those large and complex applications, because those services, the business services that are composing that application, are decoupled, and they are just loosely coupled and just independent. So that means we can change them, we can deliver and deploy them whenever we want to make any changes. That is a huge benefit, but it is the end result of a process, and we want to go over that process. Those services are small with an asterisk depending on their business functionalities, but definitely easier to maintain and to evolve, independently deployable, independently scalable, again, based on the business needs. The scalable part is an aspect usually related to the orchestration.
And this is scalable?
Scalable means depending on the number of users, exactly,
the number of requested call,
exactly, the number of requests, for example, on that application. The instances of a certain service can be increased, the number of instances, and can be dynamically increased. Again, the classical example of Black Friday.
Sure.
When people are buying way more thingies
than usual, yes.
Exactly. Then we can scale the services that are handling those, for example, I don't know, ordering. Another benefit is that the teams can be autonomous, meaning autonomous. They can make their own changes and handle their own services and just communicate with the others very.
So each team is these two pizza team?
Yes, those two pizza teams, exactly.
And they can handle their own, let's say, microservice.
Exactly. Okay. So besides eating that pizza, not the huge one, they are handling just their.
And they are responsible for that. They have ownership.
Exactly, they have ownership for that. Also, easy experimenting, meaning they can adopt new technologies, and adopting those new technologies, it is, or at least it should be, entirely business driven, based on the needs of that. Of the business. If that business benefits from having, I don't know, something implemented in Python or in R or in any other Elixir or whatever, then some services can be implemented in that. So a flexibility. Better fault isolation, because there isn't any single point of failure. That means having all those services distinct. Whenever one of them or several of them are not available, the application, as briefly mentioned, it will be just degraded, but not unavailable. There is a huge difference between something being degraded and something not being available. The overall system, meaning the overall application, becomes more efficient, more granular, more resilient, less costly after an initial investment. Less prone to big bang changes, because whenever there are some changes that are spanning across those services, of course, they need to be synchronized, but they are not done in a single place. They are distributed. So they are distributed across those services. Those services, as mentioned, can use different technologies based on the needs and based also on the development team skills. So we cannot adopt, or we should not adopt a technology just because it's the best, but we also need to have the correspondent skills. So this would be an overview of an interaction, so a visual overview. So the end users are interacting with the microservices architecture through a series of
layers.
Yes, through a series of layers. On the configuration layer would be some components which we have excluded for simplicity. On the application layer, we would have a lot of services that are communicating either between themselves, or actually both between themselves and with some infrastructure components, SQL and NoSQL database servers, message brokers, just communicating with the infrastructure services for two reasons: reading and writing data and exchanging data. So plain and simple as that. And as mentioned, in any technology, we may want to have that. Now providing a high-level overview on the phases or the stages for that migration, because as we discussed, there is a migration stage, so it's not something done extremely easy. Otherwise, I think
migration from monolithic to microservices.
Exactly, the migration for the phases of the migration. The first and most important initial phase is decomposing that application, so splitting the existing application.
The bounded context.
Exactly, identifying those bounded contexts. We'll get to them very soon. Essentially, that high-level operation is called the services decomposition. Decomposing that application where all of those services are working together into smaller services. That's the first required step. After those services are decomposed, and as we will further see, iterated over them, there is a need to establish the communication and collaboration between them, meaning the services communication mode, and then after deciding that to write and to read data. What that means in very short, after we identify those services and we split them, we need to make them to establish their communication modes. So we get the communication mode between them. And after we define that communication mode between them, we will want to implement the writing of data, so saving data consistently, and also reading data reliably, meaning in a decent response time. So these are the further challenges to be approached. And then after gladly implementing, achieving those goals, testing, setting up the security of the application, making the whole communication resilient, and integrating a few infrastructure patterns. Yes,
but if we stick to this, these three stages, hopefully or thankfully, on the last stages, we have plenty of microservices framework which exists that simplifies somehow this migration.
Exactly, they simplify a lot of those stages. Exactly, we have a lot of available frameworks and patterns for most of these steps, as we further see, both for the services decomposition. There is a domain-driven design that helps a lot, which is a series of practices. Also, in defining the communication mode, there are some frameworks that are using, but we still need to implement that. For writing data consistently and reading data consistently, again, there are a series of patterns and frameworks that can be used, but we still need to write them. So for the current 2022, developers are still required to write that. We don't have yet an AI that writes the code for us. We may have that, and then we will search for something else to do on the moon. I don't know, but until then, we need to write that. Again, the same thing for testing those services. So there are frameworks that are helping, but we need to implement them. We need to write those tests. The same for securing the application. Several frameworks, several technologies, or several ways to implement the securing, but still needs to be implemented. The same for the communication resilience, several resilience patterns, very well known and available, but again,
not
with the need.
Timeout,
retry, circuit breakers, and some others, but needing to implement them. And needing to implement them until an AI will come and do that thing for us, it's still. So it depends a lot.
Okay.
Challenges, and providing an overview on those challenges. So the first one of them, finding the right set of services is challenging. So that right is, of course, it depends. Domain-driven design can be used, so the practices from domain-driven design can be, or are recommended to be used to identify those bounded contexts and the interactions. Basically, the business context that are distinct between those services.
Would you involve some SME business experts in this domain-driven design?
That the subject matter experts and or the business analysts are definitely one of the main contributors, exactly, type of people that are involved in finding that right set of services, because they understand the application from a business perspective. So it's extremely important to understand that from a business perspective, and then to map those business perspective and business domains into some services. Again, we are always starting, or at least we should start from the business needs, from the business requirements of that application, and transitioning them to software. Software, regardless of its size and shape, it's always a mean to an end. Software is always part of the solution. The problem, or the reason of existence, is that business domain.
Yeah, how we solve the issue.
Exactly. Software is always how we solve that issue. So finding that right set of services might require very often several iterations over those defined services. So currently, as of 2022, we do not have an algorithm for finding or defining the set of services from the beginning. So they require some iteration.
How many microservices would be? If we can't find properly the boundaries, what would be the, let's say, a good number?
The answer is again entirely determined by the business domain, because the business domain will, let's say, define or determine the number of services. Most likely, in the beginning, there will be less services, meaning more bigger sized, and
then progressively you cut them.
Exactly, progressively they might become smaller. But finding the balance between a few of them and bigger, and the alternative.
Could we start the other way around? Let's say a lean approach, meaning that we have identified a bounded context that is very clear. We can make it a microservice.
Exactly.
We have the monolithic architecture that remain. They are loosely coupled with the proper communication, and we could progressively find the domain, the right domain.
Exactly, and that is also the advised way of proceeding with that transition. So using in parallel the monolith and the defined services until all of those services are properly defined. That's a technique which is called strangling the monolith, because it progressively
strangle it.
Exactly, progressively
squeeze it.
Not necessarily squeeze it, but it gets progressively decommissioned. I mean, no longer being required.
That's why we call it strangler.
Yes, it's called the strangler pattern. Again, the distributed systems are the more concept of using any distributed processing is complex, because anything in a distributed way is more complex. Development, testing, deployment is more difficult. So that is one of the reasons why not all of the applications are migrating. Features that are spanning across several services, of course, will require careful coordination between those teams and between those services. Two main hugely complex aspects: writing data consistently and reading data efficiently. These are, in my opinion, the main or the biggest challenges. Writing data consistently, whenever writing the data means across services, entails a series of challenges, entails also a series of trade-offs. So not something easy to do. Reading data efficiently, again, requires a series of trade-offs. And there are two main patterns that can be used for reading that data, but each one of them comes with... For reading data, CQRS, which is Command Query Responsibility Segregation, and API composition. One of them is more reliable in terms of, or more efficient in terms of speed, but is more complex. The other one is simpler to implement, but it doesn't have, it is not providing.
What is the second one, sorry?
API composition.
API composition, okay.
So just composing the APIs of those services and returning something in an aggregated way. So again, for most of them, there are trade-offs which need to be handled. Complexity, again, in their communication and collaboration, the same for humans, because the humans are doing pretty much the same thing as the microservices, or the other way around. The microservices are doing what we humans are doing. We are communicating in order to collaborate, regardless of the context. We are doing the same things as those services are doing. Deciding when to adopt, so that was already briefly mentioned, so a reactive way. And synchronizing those teams on coordinated changes or across several services, that's a challenge. So that's a big challenge. This overview attempts to provide a potential answer to the, I don't know, eventual question, why aren't a lot of applications migrating already? Or why don't we see that monolithic architecture in a museum and just presenting it to our kids? You know, in the past, people were doing exactly. So, you know, these dinosaurs. But these are the reasons why, because it's not easy. Not an easy migration. So a very simple example of the concept of bounded context, which is just defining the context, a business context, and the concepts that are present and available within that context.
So on one side we have delivery.
Exactly.
So we are in the context of what? Of an e-commerce website, for instance? So
most likely we are in an online shop, regardless of whatever it is, delivering something, some products, like e-commerce, yes. And we also have another bounded context, which is of financing. And in this simple example, in both of them, there is a concept of a customer. But the customer from here, the representation and the details of a customer from the delivery bounded context is most likely different from the structure and the definition of a customer from the finance, because they usually have different perceptions and different needs from that customer. So essentially, those services that we mentioned that we will identify are mapped one-to-one to this bounded context. But identifying those bounded contexts and properly defining them, that's an iterative and incremental process. So not something done, I don't know, in 2 hours or in 2 days, but something done most likely over a series of sprints. So requiring some iterations to find
no big bang. That's what we
no big bang, and more than that, an iterative process. And during that iterative process, the monolith coexists with those services, because those services are still being defined.
So meaning that you can always imagine that you have a load balancer progressively routing some of the activity to the monolith
yes, to the monolith and to the services, the new defined services, those services which are an ongoing process to be refined. Some patterns that are helping a lot in the process. So in order to implement, after defining them, there are a series of patterns that can be used. So a lot of architectural patterns and components and practices. We can use a lot of patterns in order to do that. There are 3 main macro categories of patterns that we can use in order to implement the other concerns. So we discussed a lot about the first part, which is the splitting. So identifying those services. After we identify those services, we will want to make them communicate and collaborate. And for that, we have a series of patterns. So application patterns, application infrastructure patterns, and infrastructure patterns. Of course, that is one way to provide the categories for them. Most likely there are some others. These are inspired from the microservices pattern language book, highly recommended book in case you want to go deeper into them. And essentially, these patterns are very, in my opinion, very simple to understand, because in any context, we have an application that is interacting with the infrastructure. Absolutely every application. And we have a series of application patterns which are concerned to the application itself, to the interaction between application and the infrastructure, and some patterns which are entirely related to the infrastructure. So again, these categories are helping us in that transition. So they are not performing any magic.
Best practices.
Exactly, best practices and already established guidelines on doing that.
We need to conclude, so let's...
Sure, I'll just present this and we can safely conclude that. So to provide an overview, the planning and design, we have already discussed a lot about services decomposition. So we discussed that that's the main and the first initial challenge and something that needs to be done. So that means decomposing those services and then establishing a few details for them to collaborate. So that those will be partially in the infrastructure or application infrastructure, decomposing them and setting up the necessary infrastructure. Afterwards, development and testing. So after we decompose them, we want to develop and to test, especially their communication style. which can be synchronous or asynchronous. This might be a topic.
We didn't touch upon that.
We didn't touch upon that because it's a huge topic and trying to squeeze it as much as possible.
What does it mean asynchronous? Maybe just for 1 second.
Synchronous means a communication style which keeps the two parts. HTTP, it's the most well-known communication type. It is a blocking and unreliable communication model. Asynchronous, in short, it's a communication via messages, which is not keeping any of the
message broker.
Through a message broker usually, and which is not keeping any of those parts blocked, but which also requires more development effort.
So just 1 sec. So if in this case synchronous communication, would we keep in a microservice architecture some part being because I understand that it's unreliable. You mentioned that.
Yeah.
But the communication front to back can still remain synchronous.
Most likely it will remain synchronous, but the discussion in here, the communication style, it's entirely referring to the service-to-service communication.
Okay,
so not from the
preferably would be asynchronous.
Asynchronous, yeah, to have that communication reliable.
Let's conclude, Bogdan, so that we can take some question from the audience.
If we have any questions,
Alex.
Yes, hi guys. I kind of try to pull all the questions and paste them in the chat, in the private chat. So if you have the StreamYard chat somewhere,
which to the so
yes, that one.
Yeah, what approach?
Yeah, can you read them? And
I'll try to read them, of course. So what approach best practice do we have to quickly trace requests which under the hood imply interactions between multiple microservices? Thank you, Mihai, for the question. In short, we have a series of distributed calls, let's say monitoring frameworks. Some of them might be, I'll quickly try to provide the context. Open Zipkin might be for doing that, or Open Tracing. Essentially, these are two applications that can be used, or two frameworks that can be used. Open Tracing as well. So tracing those calls, not something easily, or I don't know, easy to implement. Again, sorry, this has been migrated to Open Telemetry, which is again, yeah. So enable effective observability between those services, because there are a lot of calls being done between them. Important to mention that these frameworks support both synchronous and asynchronous communication, so we can monitor the two types of communication in there. Fast forwarding, trying to answer on the other. Middle ground between them, modular monolith. Transition is easier from these two microservices. Totally agreed, mentioned that, and as you also mentioned, a middle ground between them.
Mm-hmm.
Why monolithic architecture must use a single technology on the back end, on the front end? The reason why they must use a single technology is that we have a single deployment unit. So we have a single deployment box, and that deployment box, which usually might contain both the front end, meaning usually a JavaScript application, and the back end, Java or something else. But the deployment unit, the deployment entity, is actually running a single technology. So running just one of them. If we have a distinction between the backend and the front end, then of course we no longer have that requirement, but we are automatically using two deployment units. One of them is for the backend, and another one will be for the front end. So again, if we are bundling everything within a single application, then we are packaging both the backend and the front end. Then we have that, let's say, restriction on the execution. If we are using two deployment units, then we have the backend in one and the front end in another one. So hopefully, Carmen, hopefully that provides enough context. A way to start, build a monolith application such a way that if successful enough, we can easily switch to microservices when needed. What should we have in mind when we are at the start? Yes, thank you for that, Bogdan. The shortest answer that I can provide is that those services should ideally communicate through properly defined APIs. So defining those APIs for the services.
We are still at the monolithic, let's say, stage.
Yeah.
Can we still, let's say, separate the code so that, okay, when we will need to move to microservices, it will be easier?
We can, but it's much more elaborate from the beginning. Because especially in the object-oriented world, it's much simpler to just invoke a class, just invoke a service, than call another service through either HTTP or through messaging. So we can, but we need to pay more attention and involve more effort in the beginning in order to separate the communication between services. So the easier way will be always to use class calls, faster, easier to implement. The future-oriented or future-ready way will be to invoke them via an API. So that's the yes.
Remember, we wanted to offer a book to the best question. I
think that's had a very
very
good question.
Let's look at the other one.
What do you mean by lightweight JVM? Isn't the same JVM used for monolithic microservices? Thank you for the question, Andrei. By lightweight, I'm referring to a JVM which contains just the minimum amount of classes needed for running that application. Meaning just the set of classes and, of course, dependencies that are needed in order to run a service. But one service, not 5 or 20 services, meaning the business services from that application. So that's why. Isn't the same JVM used for monolithic microservices? Again, this entirely depends on the JVM that is used. We do not have enough time to go over JVM differences, but in short, there are so many JVMs available, and so we can choose whatever we want. Might be the same JVM, might not be the same JVM. There is also an initiative for the Graal VM, for example, to go to native Java applications, which are just being much faster to start. Quickly go, hoping or trying to answer the other ones. If the customer entity in the second bounded context is the same, no, most likely not. Is it kept physically in two separate tables, or it was only a logical split? In which case, how do you handle writes from both bounded contexts? Thank you, Emmanuel, for the question. So is it kept physically in two separate tables? This is a question on which the answer is it depends on how do we plan to use the databases. Meaning we have two essential possibilities. Using a single database for all of those services, which has some benefits, or using two distinct databases. If we choose the one database per service, then that means it will be kept physically in two separate tables. How do you handle writes from both bounded contexts? The shortest answer that I can provide is using the Saga pattern. The Saga pattern is a pattern of handling distributed transactions, and distributed transactions coordinated through messaging, not something new, not something as hipster as the microservices are, but a pattern that exists since 1987. So the Saga pattern is a long time ago. But someone said, like good old wine. So like good old wine, we can have a pattern for that. What if you want to scale one of the microservices? How can you handle concurrent writes, which might try to create, update the same record? Do you possibly get duplicates and overwrites? Again, so let's take the questions distinctly. How do you want, or what if you want to scale one of the microservices? The scaling aspect, it's easy to do because that's an orchestration aspect.
Sure.
And we just
scale.
Exactly, Kubernetes. Exactly. It's just a matter of configuring one of the Kubernetes objects, which is called the replica set. So just providing the number of instances. How do you handle concurrent writes, which might try to create an update? Again, the shortest answer is using the Saga pattern and using a few countermeasures, software countermeasures. But those software countermeasures, again, involve a lot of effort to write them. So not something very easy to do, not something that we can very easily implement. So Saga pattern would be the same answer.